Okay, today is March the 27th, 2016. It's about 2:15 in the foothills of Los Angeles. Currently, we have a temperature of 72 degrees. The humidity is 40%. The dew point is 51 degrees. And the barometric pressure has risen to 1,016 millibar, or 30 inches even. All right, so right now, we're keeping an eye on the eastern East Pacific because there's a very large thunderstorm right here that's being blown apart with microwave. And we've got some pretty good evidence right here on the loop. We have on the visible light mode, we can see several crater marks all through the center of this core right as it's being targeted. And what's happening here is that the microwave is superheating the core. That is, the water vapor is being superheated. We have rapid expansion radially from the core, and we have a blast pattern all the way around this edge. We can see the features of that all the way around. We can see this feature right there, that ring. And we have a big change in the, we have this over here in the, let me move the camera over. We have the color change. We have the magenta right here. This indicates a very intense thunderstorm activity. And we can see what happens here over a few seconds. Well, actually, this is a 7.5 hour loop, but we can see the color diminishment there. Let's look at the infrared loop. We can see the same thing, the blast pattern, and we have the color change. But the next map here is the visible light mode, and we can see right here, we have some great evidence. There are 1, 2, 3, 4, 5 crater marks right as this system is being hit. Let's go ahead and roll this, and you can see what happens. Let's go ahead and stop this and just, this is the very beginning of the sequence right here. We have that first area is hit. There are several rings that expand out radially from both sides of the target point right there. Same here. We've got 1, 2, 3, 4, and 5. And this one up here actually generates that big ring that we're seeing in the and notice this right down here, this feature. This is a ring of water vapor that's expanding out from superheated water vapor in that core. I don't know if you can see that here, but if we go from the first frame to the next frame, all those rings become much larger. Particularly this one right here, right there. That one is all by itself. That doesn't show up on the first frame. We have 1, 2, 3, 4, 5. And in the very next frame, we've got one way out here. Now watch what happens. I'm going to keep the pen here and look at the right off the tip of that pen is the attack that occurs in the second frame. I just really hope everybody can see that because this is some really good evidence. Let me stop it here. Let's just zoom in a little bit, see if we can capture some of that. Yeah, the second frame, there's that mark right there. Right there. First frame we have 1, 2, 3, 4, and 5. And in the next frame we have this one. And that is the evidence of the microwave hitting this system, superheating the core, and we have rapid expansion And those thunderstorms are heated, they're superheated, and then we see the what happens next. If we go back to the here to the infrared loop, we can really see what's going on here. I'm going to get the camera zoomed out, get this centered up properly. We can see a large area right here, a blast pattern, very rapidly expanding water vapor and air shooting out from that one area there. But all around the entire storm, we can see the evidence of a blast pattern, and that's what's happening here. This is how they control and destroy hurricanes. They use high pressure on demand to steer these storms. They use the high pressure from the transmitters, the HARP or the phased array transmitters, to generate high pressure to steer these storms away from land, like we saw all last June, July, and August. If you look at my videos last year from June, July, August, and September, you'll see great evidence, like what we're seeing here, of some of these hurricanes being steered around Hawaii and all the rest of it. So it's really good evidence. Let's go take a look at the this is the northeast Pacific water vapor loop. And we have an area of low pressure right north of Hawaii, which is trying to spin up, and this is all being isolated by a transmitter. We have a margin right here. This is an electronic wall, I call it. This is going to separate this jet stream moisture field from feeding this system right here, which is being attacked. We can see what happens. It's actually the core of that just disappears right there. And then we have all this flow moving right into Southern California, and that's why we have the jets are out spraying today, because we actually have a shot of rain today. We have all this moisture moving right into Southern California, right here. We go and look at the infrared loop. We can see all that moisture moving right in. This should have brought some light rain. We have a jet stream flow here. This is all being separated, though. We've got high pressure all through here. That is going to keep this separated from that. We also have a right angle up on this system. There's a radar, a phased array radar, focusing heat on this storm. This is like a 965 millibar storm system. If we go back to the water vapor loop, we can see that very clearly. If I had gotten up earlier around 8 o'clock this morning, we would see a perfect right angle on one of those frames. But it's a little bit past that. We're a little less than 90 degrees there. But that's obviously being manipulated by a transmitter. This is actually a rectangle here. We've got a huge area that's being targeted. Phased array radar is highly directional, and they're heating this entire core to weaken it. This system is actually moving to the east-southeast, so we've got a huge area of high pressure that's being built in right here. We'll take a look at that right now on the surface analysis map. We can see that 965 millibar system moving to the east-southeast. We have a huge cold front, but look at here. This high pressure is completely expanded outward, and this is going way up into the Gulf of Alaska. Here we can see a lot of this high pressure. We have a developing gale here, a trough, and we were supposed to get some rain moving down into right between these two areas of high pressure that brings some rain, and that probably won't happen because the pressure now has risen to 30.00 from last night. We had lower pressure last night. Looks like they're pumping things up because this is a big storm, and now it's moving to the east-southeast. All right, next we have the same picture here. This is the sea level pressure map. High pressure firmly installed all through the eastern Pacific Ocean and North Pacific as well. We have a low indicated right here over San Felipe, Mexico. All right, and I don't know if I mentioned the temperature at about 2:20 in the afternoon. We've got a 72 degrees. The relative humidity is 41%. Dew point is 52 degrees. And the barometric pressure is 1,016 millibar. I think I may have mentioned that already, but anyway, there it is. Okay, tropical Pacific water vapor loop. This is the wide angle. We can see that storm here. This is, or rather, this low pressure is being destroyed with high pressure. They've got a transmitter destroying that. It just vanishes. The core of that is just disappears. Okay. This is the infrared loop. All right, we're back to that water vapor loop I was showing about. The that storm system is being destroyed. We can see the diminishment, and we can see the actual targeting points. Microwave. You're hitting this with coherent microwave, probably a maser, M-A-S-E-R, that preceded the laser technology. Okay, and here we are. This is our area. We can see the chemtrails being sprayed right through here. All right. So we have a shot of rain today, but the chemtrails are causing a capping inversion layer, so we will not have lift. You have to have lift and moisture to get rain. The chemtrails stop the lift. At about 40,000 feet, they spray these aerosols, 40 to 45,000 feet, and that causes the capping inversion layer, and we don't have lift. We've got a hot air layer above the cooler air, and that prevents the lift, and that's why we're not having rain. Okay, next is the jet stream, and we can see that there. It's coming up way up into the Gulf of Alaska and then down into Oregon. So that's the summary. We'll just leave it here. We can show that right angle. This was probably a really nice example of a rectangular phased array radar attack on that low pressure system. This is a storm, and we'll do another update later. That's it.